day, everybody! So, as we all know, before anything else, in conducting researches, especially if those researches are under agricultural or experimental researches, it is important na kina-clarify natin what kind of methods we're gonna use to obtain our data corresponding our topic. And so, those data gathering methods, meron tayong mga experimental designs, which are, in example, CRD, RCBD, and so on. But in this report, we're just gonna focus on the completely randomized design. The completely randomized design, or the CRD, is known as the simplest experimental designs in comparing differences between treatments. And sa report na to, we're gonna focus on that, on the advantages, the disadvantages, the uses, or even give you a sample problem para ma-simulate tayo ng knowledge about the CRD. And before anything else, my name's Luella Dominguez, together with Marjorie Domingo, Joy Brian De Rojas, Alisa Pacubas, and Patrick J. Mendoza. And once again, ire-report po namin yung completely randomized design, or the CRD.
Good day everyone, my name is Marjorie I. Domingo, and this report is all about completely randomized design, or the CRD. At ano nga po ba ang CRD? It is known to be the simplest type of experimental design because this allows all experimental unit to have an equal probability of receiving a treatment. CRD po is also a type of experimental design that are randomly assigned to different treatments. It means for CRD, kapag ang experimental units ay naka-receive ng same treatment, it is considered up po as experimental error. CRD subjects are assumed to be the homogeneous, which all the experimental units are taken in a single group, which are yun nga po, homogeneous as far as possible where the environment is controlled. And for the uses of CRD, it is appropriate po when the experimental units are believed to be uniform. That is when there is no uncontrolled factor in the experiment were measured during an experiment na pwedeng makapag-influence po sa result ng experiment natin. And CRD is also used in experiments with homogeneous experimental units that are uniform as possible in all characteristics that could affect the response. And also, CRD is appropriate for laboratory and greenhouse experiment. For this, to control the environment in which all the experimental units have the same conditions or being homogeneous po.
The CRD's advantages. There are 5 types of CRD's advantages, which is the flexibility, unbiased, statistical efficiency, independence, and wide applicability. For flexibility, it is an experimental design that allows us for easily modify and adjustment. It is also useful for dealing with unforeseen circumstances or changing research needs.
Second advantage of CRD. CRD is unbiased because treatments and control groups are randomized at random. CRD removes any potential bias from the experimental designs. This also implies that any observed differences between the groups can be exclusively attributed to the treatment, with all parameters being held constant. Unbiased raw po ang CRD dahil kumbaga walang favoritism na nagaganap sa all treatment. Dapat po lahat is pantay-pantay. Kung ano meron sa treatment 1, dapat meron din po sa treatment 2 and treatment 3 and so on and so forth. Ganun po. Pantay lang po. The third advantage of CRD is statistical efficiency. The CRD is known for its statistical efficiency, when enables it to achieve necessary level of statistical power with minimum sample size. This can save a lot of money and shorten the duration of the time. Ang statistical efficiency naman po ng CRD is kahit na sample size lang po ang gawin nyo is makukuha nyo pa rin po yung tamang information and data about dun po sa study nyo po.
For the independence it is an experimental unit in CRD which is completely independent for all other units. This makes it easier to identify and measure the treatment effects.
And the last advantages of is broad application. CRD is a flexible and broadly applicable experimental design that can utilize in variety of domains like psychology, medicine, and agriculture. Malawak po ang pwedeng paggamitan ng CRD, lalong-lalo na po sa field ng agriculture, medicine, psychology, environmental science, engineering, and education. As long as nagkakandak po ng research. And pwedeng-pwede po nilang gamitin yun as their experimental design. Thank you po.
So, ang susunod naman natin dito ay mga disadvantages of CRD. Siyempre, kung merong mga advantages, meron din naman tayong mga disadvantages. And ang una nga dito ay ang lack of control. With CRD, there is no control over external factor that may influence the experiment outcomes. This can make it difficult to isolate the effects of the independent variable on the dependent variable. So, ayun. For example, sa ating study, ang study natin is the effectiveness of different types of indigenous microorganisms in the growth of yield of mung bean. So, meron ditong ibang mga factors na maaaring makaapekto bukod sa pag-a-apply natin ng microorganisms sa ating plants. Ano yung mga factors na yun ay, halimbawa, ito ay yung climate, yung bigla ang sobrang pag-init o pagbaha. Siyempre, kapag bumaha at nag-apply tayo ng ating IMO sa ating crops, merong ditong, kumbaga, dahil sa baha is maaaring mag-leach ang ating mga organisms na in-apply sa ating crops. So, ganoon din sa bigla ang pag-init na nakakaapekto ito sa ating mga crops na maaaring mamatay or magkaroon ng mga diseases and so on. So, ang susunod ay inefficient use of resources. In some cases, CRD may require a large sample size to achieve statistical power, which can be inefficient in terms of time, resources, and cost. So, insufficient use of resources. Ang CRD ay nagre-require ng large sample size. So, ibig sabihin, gumagamit ito ng malaking size, big size. Kasi mas malaking size ang ginagamit to represent the population. Like for example sa ating study, ang ating kinukuhang study is study habits of CLSU student. So, siyempre, pag sinabing CLSU student, hindi pwedeng College of Agriculture lang ng mga estudyante ang ating kukunin, kundi lahat ng department na nakapaloob sa CLSU student. So, dahil hindi pwede na kaglang ang pagkukuhanan natin. Hindi pwedeng, kasi sa ganong paraan ay hindi natin ma-generalize ang ating conclusion. Kumbaga, subjective lang ang ating study sa College of Agriculture, hindi sa CLSU students. College of Agriculture students lang, not CLSU students. Ang susunod ay limited ability to detect interactions. CRD is not ideal for detecting interactions between variables. This is because interactions may only be detected when certain variables are combined and CDR treats each variable as dependent. So, hindi makikita ang interaction ng mga variable under investigation. So, kung ano lang ang nakikita sa variable na yun ang nade-derive ng conclusion dahil nga combine yung combine ito independently. Like for example, meron tayong apat na treatment sa using of different types of IMO in the growth of mung bean. So, treatment 1, treatment 2, 3, and 4. So, pag sinabi kasing CRD, kwan lang siya, independent. Kumbaga, ito, treatment 1, independent lang siya na i-combine sa ating crops sa local mung bean. Treatment 2, independent sa local mung bean. Treatment 3, ganun din. Treatment 4, ganun din. Independent sila sa isa't isa na kasi homogeneity assumption, one variable, isang treatment, siya lang. Ayun, one variable, isang treatment, siya lang. So, susunod naman natin is homogeneity assumption. CRD assumes homogeneity. So, ayun na. Limited to detect interactions. So, homogeneity assumption. CRD assumes homogeneity of variance and covariance across treatments groups, which may not always be true. This can be lead in accurate research and conclusion. So, ayun nga. Dahil since ang CRD ay independent siya, merong homogeneous assumption na it is not always true. Dahil ang nakikita lang naman natin ay yung ano ba ang interaction between treatment 1 natin and sa ating crops. Ganon din sa treatment 2 ating crops, 3, crops, 4, and crops. So, syempre, merong mga factors na hindi natin nakikita kung paano ba talaga nag-i-interact ang ating mga variables sa ating crops, sa ating mung bean. So, next slide is may not be suitable for complex experiment. CRD is relatively simple experimental design and may not be suitable for complex experiment that involve multiple variables, factors, and treatments. So, ayun nga. Hindi suitable dahil hindi nakikita kung ano ang interaction ng apat na variable tulad ng sabi ko kanina sa ating plants. So, hindi siya suitable. Kapag complex experiment kasi, kailangan i-compare yung apat na treatment na ito no kung ano ba talaga yung effect niya sa ating crops na gagamitin. Ayun yung pag sinabing complex. So, hindi siya suitable for complex experiment dahil nga ang CRD ay independent na kung saan treatment 1, independent lang siya sa ating crops, 2 crops, gano'n. So, hindi siya suitable for the complex experiment. Kung ano lang yung na-derive na conclusion between independent variables sa dependent variables. So, independent variables yung ating mga treatments, sa dependent variables ay yung ating crops. Ayun lang yun. So, kaya, ang isa sa disadvantages ng CRD ay hindi siya suitable sa mga complex experiments. So, ayun lang yung mga disadvantages ng CRD.
So, given CRD's advantages, disadvantages, and uses, let's proceed dun sa application ng CRD. So, CRD is only used sa mga homogeneous. Kanina diniscuss na it is only used sa mga homogeneous experimental units. And yeah, because as I told you earlier na simplest din siya since it only aims to see or to project if may significant difference ba between the treatments, but it does not accurately say what treatment doon ang may significant difference. Let's go here with a simple problem. So, in step-by-step solution, we have an experiment conducted to determine the effect of water types, distilled water, groundwater, freshwater, and rice water, which are our levels, sa emergence ng symptoms sa bastard. So, each treatment is applied to each respective plots. So, if you can see, down below, meron tayong null hypothesis, alternative hypothesis, and the decision rule. So, our null hypothesis stated na walang difference between the treatments. However, in contrast, sa alternative hypothesis natin, at least one has difference. And then, ang decision rule natin sa CRD is to reject the null if F computed is greater than F tab. And then, we're gonna go, before anything else, it is important na maging familiar tayo sa mga gagamitin nating formulas and parameters sa computation or sa manual computation ng CRD, since this will be our basis for the values that we're gonna take. So, FC is our formula computated na nakita natin kanina sa ating decision rule, wherein if FC is greater than F tab, then let's reject the HO or the null hypothesis. Where, given sa below niya, yung FC is equals to MSTR over MSE. And then the F tab, the formula tabulated, where F tab is equals to F alpha and T minus 1 and minus T, where T is our treatments and N is the total number of replicates. So once we gathered all those data sa F tab, we can find yung mga values dun sa F distribution table natin na madidiscuss natin later. So N, as I said, is the total number of replication. T is the treatments and level of significance. So about the level of significance, it varies depending sa instruction ng professor, ng mga instructors natin, or dun sa sa standard ng institution or ng college. For example, sinabi ng instructor mo na 0.05. So, we're gonna use that 0.05, and then, given sa mga values na nakuha natin sa FA, T minus 1, N minus C, hahanapin lang natin yung mga values na yon sa F distribution table at titignan natin kung ano yung nagko-correspond sa pair of values na nakuha natin. So, MSTR is treatment mean square, and the MSE is the error mean square. Since we have to find the F tab, let's go to the next slide. But before anything else, syempre kailangan nating ipakita yung data natin na kukuhanan natin ng CRD. And then we have the 4 treatments, which are distilled water, groundwater, fresh water, and rice water, na naka-indicate sa y-axis, and then sa x-axis ay yung mga replicates natin. And then along that, the rest ay yung mga data natin. Yung data natin sa replicate 1, depending on its treatment, and so on. And then in replicate, since we have 10 each, we have a total, and we have 10 each. And if we have 4 treatments, we have a total number of 40 replicates. And then if we're gonna sum it all up per replication or per treatment, we have sa distilled water, we have 3. Sa groundwater, we have 31. And fresh water, we have 33. And the rice wastewater is 46. So, I stated there na ang maximum numbers ng mustard at maturity stage is 8 to 9. So, wala namang naapektuhan na number of leaves na umabot ng 8 or 9. So, we can just see na 7 doon. So, if you saw a 10 there, that would be questionable. And then, let's go back to the decision rule, which is to reject HO if F computed is greater than F tab. Since F tab is equals to F alpha, T minus 1, and N minus T, then, let's go back, let's fasten the discussion, magiging 3 and 36. And then I search on the internet or the credible sources in which ano ba yung magiging corresponding value sa F distribution table ng 3 and 36 if ang level of significance ko ay 0.05. So, I got 2.87. Now, we already have our F count, but we don't have something to compare it to. If it's lesser or greater, we have to find the computed para magamit natin yung decision rule. The F computed para magamit natin yung decision rule. And then, we have here the guidelines to find the F computed. We can see na medyo complicated siya, but then, if we try to solve it step by step, maybe we'll realize na, it's just a piece of cake, something like that. But, yeah. And then, the parameters that we're gonna use is the treatment degree of freedom, the error degree of freedom, total DF, the correction factor, the TSS or the total sum of squares, the treatment sum of squares, the error sum of squares, the MSTR, the MSC, and the FC. So let's start on the treatment degree of freedom. Okay, T minus 1 lang siya, in which if we have 4 treatments, minus 1 will be total of 3. And then let's go sa error DF, n minus t, if we have a total of 40 replicates, minus 4 is equals to 36. And in a total DF, as simple as that, like the rest, n, or the number of replicates, minus 1 equals 39. So let's go naman sa correction factor, in which you can just see the formula because hindi ko siya masabi, basta summation of something like that, and then, pero, yung nandun sa numerator lang, ang ini-state niya lang dyan, what it's trying to state is the grand total of all sa mga values ng replicate. So, if we're gonna go back sa previous slides, we have a total of 113. So, we're just gonna square that 113 divided by the value of n, or the number of replicates, is equals to 319.225. And then let's go sa total sum of squares. The total sum of squares, so it was just trying to state na kailangan nating i-square lahat ng replicates, lahat ng values ng each replicate. So if we have 0 squared plus so on, and then we're gonna subtract it to yung nakuha nating correction factor, which is 319.225 is equals to 141.775. So we already have our treatment DF, our error DF, total DF, correction factor, and TSS. Now let's go naman sa treatment sum of squares. So what I was just trying to say, yung formula, sinasabi niya lang doon na kung ano yung value ng replicates in each treatments, or yung total ng each treatments, isa-sum lang natin per replicate. So, 3 squared divided by 10 kung ilang replicates sa treatments na yon, plus 31 squared, we have total of 31 sa treatment 2 divided by 10, and so on, 33 squared divided by 10, plus 46 squared divided by 10, and then we're gonna subtract it again sa CF, or the correction factor, which is 319.225 is equals to 98.275. So after that, pumunta na tayo sa error sum of squares. So since we already find our TSS and TRSS, we just have to subtract it by each other. So 141.775 minus 98.275 is equals to 43.5. And then, the MSTR, so alam naman natin, kanina, to find the FC, we have to find the MSTR and the MSE. So we're already in MSTR. So as simple as that, ang TRSS, ang nakuha nating TRSS ay 98.275 divided by yung treatment degree of freedom, which is 3, is equals to 32.76. And then, let's go sa MSE, since we already have our treatment mean square. And then, now let's go sa error mean square. So, ESS minus error DF, so 43.5 divided by 36 is equals to 1.21. So, since meron na tayong MSTR and MSE, and those are the parameters need to compute the F computed or the FC, we're just gonna divide MSTR and MSE. So 32.76, which is this MSTR, divided by MSE, which is 1.21, is equals to 27.07. And then, let's satisfy the ANOVA table. So, yan yung mga values na na-compute natin kanina sa parameters na values na kinompute natin kanina para makuha yung FC. The sources of variation, we have treatment, error, and total. Sa degree, yung 3, 36, and 39 kanina. And then the sum of squares, lahat lang yan nanggaling doon. So, you're just gonna look dun sa previous slides, yung mga data na nagko-correspond dito. And then, since we already have our F computed, which is 27.07, and our F tab is 2.87, we have to remember the decision rule. So what is the decision rule? It is to reject null hypothesis if F computed is greater than F tab. So, our inferences or our decision in remembering the decision rule, sa base sa results na nakuha natin by manual computation, computed F with a value of 27.07 is greater than tabulated F with a value of 2.87, therefore rejecting the null hypothesis. So that would mean that we have to accept the alternative hypothesis in which ang interpretation natin, we concluded na merong pagkakaiba between the given treatment satisfying the alternative hypothesis. It means that there is a relationship between all the treatments, that there is a difference between emergence ng symptoms sa distilled water, sa groundwater, sa freshwater, and sa rice wastewater. So, that's how you simply solve the completely randomized design. And if you can see if applicable ba ito sa research mo, maybe you could use this, especially if you have homogeneous experimental units. So that's all. Thank you.